Welcome to the class, dear students. Yes, in the last video, we have done the integration by parts. That is the third method of integration. Now, in the same integration by parts, there is a small shortcut method is there, which is given by the Bernoullis. That is called as Bernoullis form of integration by parts. So now, in this, what we do is integral udv is the same formula, but we write in a shortcut way. That is uv minus u dash v1 plus u double dash v2 minus u triple dash v3 and so on. What are these u dash, u double dash? These are the successive derivatives of the function u. Whereas v1, v2, v3, these are the successive integrals of the function v. And selection of this u and v is being done by Euler principle, but at the same time this particular form is only applicable only when there is a algebraic function present in the integrand. So this rule can be applied only if there is an algebraic function in the integrand. That means it should be like x or x square, like that. That algebraic function should be present in the integrand. Then only we can apply this Bernoullis form. But it really saves so much of time to solve the integral. As I told in the last video that if the integral is having x square or x cube or x power 4 or something, then we have to do 2 times the integration by parts. Instead of doing 2-3 times, we can use this method very easily. Actually, it is a boon for the people who are applying this particular method actually. So let us now have a small problem so that we can understand very easily. For example, integral of x cube e raised to ax dx is there, suppose. Now, what is the function? Algebraic function is there, correct? So there is an algebraic function. Therefore, this rule definitely we can apply. So now let us see what it is. So when I say this is exponential function, therefore that is dv, of course. Then let us have this u as x cube and dv as e raised to ax. Now what we have to do is we are going to differentiate this successively. That means x cube derivative becomes 3x square. 3x square derivative becomes 6x. 6x derivative becomes 6. 6 derivative becomes 0. So now we have to integrate. So this is the method where you are using both differentiation and integration very parallelly we are doing. So now what is the integral of e raised to ax? Integral of e raised to ax is e raised to ax over a. Now its integral is e raised to ax over a square, and then its integral e raised to ax over a cube, and then its integral e raised to ax over a power 4. Now you can extend, but here on the top when you have 0, you have to stop this process of continuing the different integration. I hope you could understand. Whenever there is 0 on the top, you should stop integrating in the next continuously. So successive integration will be stopped when there is 0 in the top. Remember that one. So now let us go on to find out the terms here. So now what we do is we take this multiplied by this, not the below one, just the term which is the diagonally next line. This is multiplied by this, and this is multiplied by this, and this is multiplied by this, and of course 0, there is no other term. Okay, so now let us write down for the answer here. That is x cube is this term. X cube will be multiplied by this term e raised to ax over a. So now x cube multiplied by e raised to ax over a, and then the next term is 3x square multiplied by, that is 3x square here, that is multiplied by e raised to ax over a square. So e raised to ax over a square, and the next term is 6x times of e raised to ax over a cube, and the next term is 6 times of e raised to ax over a power 4, and then of course the constant. Now all these terms in between, what you have to do, always start with a plus sign. Alternatively you have to put plus and minus. So plus minus plus minus. So the constant is of course plus. Now whatever, suppose some in calculation is needed, suppose you can do it. Now here there is no need of any calculation here. So simplification is not needed. So we can write like this. This is what the value of the integral. Really it is a very fastest method to find out the value of the integral by using this technique of Bernoullis form of integration. I hope it is understood. So let us now go to the next problem. So let us solve the next problem. The next problem is, you have, suppose, integral of some x cube times of cosine x dx is there. So it is understood we have to use the by parts, and also algebraic function is there. Hence you can apply the Bernoullis form. So what is u here? U is x cube. And what is dv? Let us rewrite this one. This dv is given by cosine x. Now x cube derivative 3x square, its derivative 6x, its derivative 6, its derivative 6, its derivative 0. Okay. So now its derivative is 6, its derivative is 0. Now cosine x integral is sin x. Now sin x integral is minus cosine x. Minus cosine x integral minus sin x. Minus sin x integral cosine x. Okay. So this is what you should remember. Cosine x integral is positive sign. Sine integral is negative cos. But cosine integral is sine, but there is negative, so negative. So sine integral is negative cos, but there is minus, so it is positive. So it's understood. Now what we have to do? Take down these products with the diagonally in the next term. So like this you have to take the products, and then what we do? We write down the products here first. So the solution is x cube sin x 3x square times of minus cosine x. Better don't put alternatively plus minus now only. First you write down the terms properly, and please remember, whenever there is negative sign, immediately put a bracket, otherwise you will get confused. 6 cosine x plus the constant. And now you start putting the plus minus plus minus. So now let us see the value. The simplification is x cube sin x. There is minus of minus, so it is plus 3x square cosine x minus 6x sin x minus 6 cosine x plus the constant. So this is the solution of the given integral. I hope it's clear. The Bernoullis form is clear. Now let us go to the next problem. Let us take the function as x secant square x, suppose. The third problem now is, let us take integral of x secant square x dx. So now what you do? You will write, this is also algebraic, so we can use the Bernoullis. So u is x, x derivative is 1 and 1 derivative is 0. And then dv is secant square x. What is the integral of secant square x? We have done yesterday's in the last video. What is the integral of secant square x? Is tan x. And tan x integral is secant x, ln of secant x. Tan x integral is ln of secant x. So let us put that value, ln of secant x. And now start taking the values here, taking the products here like this, like this. And now the values are x times of tan x, and then ln of secant x plus the constant plus minus ln of secant x. So no need of any simplification. So the answer is this only. Is it clear? The answer is this only. Now let us go to the next problem. Integral, the fourth one is integral of x square minus 5x times of e raised to 2x dx is there, suppose. Now there is also algebraic. So first we take u as x square minus 5x and dv as e raised to 2x. Now the derivative of u is 2x minus 5 and its derivative is 2 and its derivative is 0. And then e raised to 2x integral is e raised to 2x over 2. Its integral is e raised to 2x over 4. Its integral is e raised to 2x over 8. Why? Because why it is 4? It is already 2, already 2 is there. So when you integrate again, it becomes 2 into 2 and again it is 2 cube like that. And now multiplying this and this and then this. So that gives you now x square. The solution is what now? X square minus 5x times of e raised to 2x over 2. Now the next term is 2x minus 5 times of e raised to 2x over 4. The next term is 2 times of e raised to 2x over 8 plus the constant. So let us have now the plus and minus and then plus, and then of course the constant is plus. I hope you could understand. So you can do the calculation here, the simplification, 2 1s and 2 4s. Here no, you cannot do anything, so keep it like that only. So this is what the problems you can do easily by using the shortcut method. It really takes very less time to solve the problems. When the rule is only if there is the algebraic function. Now let us go to the next problem. The fourth problem is over. Now I am going to do the fifth problem. That is, suppose you have x power 5 times of e raised to 3x dx is there. Then how to do it? What is u? Then there is algebraic. So u is x power 5 and dv is e raised to 3x. So what is x power 5 derivative? It is 5x power 4. Its derivative is 20x cube. Its derivative is 60x square. Its derivative is 120x. Its derivative is 120. And its derivative is 0. Let us I will shorten this one. Let us have this one in a short way so that I can complete it in this one only. U is x power 5. Its derivative is 5x power 4. Its derivative is 20x cube. Its derivative is 60x square. Its derivative is 120x. Its derivative is 120 and its derivative is 0. Is that clear? So now let us see the integral part. The integral part is here dv is e raised to 3x, that is e raised to 3x over 3, e raised to 3x over 3 into 3 which is 9, e raised to 3x over 9 into 3 27, e raised to 3x over 27 into 3 81, e raised to 3x over 81 into 3 243, e raised to 3x 243 into 3 becomes 2 and 729. So let us now do the calculation here. This into this, this into this, this into this, this into this, this into this and this into this. So if you want to do without Bernoullis theorem, suppose Bernoullis properties, this law, suppose, then it is you need to do this differentiation by using by parts more 5 times. You have to repeat the process. Otherwise, it is very easy by using this method. So the terms are x raised to 5 e raised to 3x over 3, then 5x power 4 e raised to 3x over 9, and then 20x cube e raised to 3x over 27, and then 60x square e raised to 3x over 81, and then 120x e raised to 3x over 343, 120 e raised to 3x over 729 plus the constant. So you can put plus minus plus minus plus minus. So now you can do the simplifications also. So what are the simplifications you can do? 20 and 27 cannot be done. Of course 60 and 81 can be done. 3 20s and 3 27s, and this is 3 40s, and this is 3 43. I think it is not possible, so it is 120 like that only. 120x over 343. That's 310. Then this is possible. 11 plus 7, 18 is divisible by 3. So this is possible. So 340s, and this is 3. It is 243. No? E raised to x by 243 it is. And this is also 243. So it goes on. So 243 plus 3. So like that you can do the simplification, and this is the solution. So now let us go to the next very important problem is, let us say the problem is like this. Suppose sixth one. Okay. Integral of e raised to x sin x dx is there, suppose. Now how to solve this integral? So first thing is, it is very clear that by parts you have to use. But can we use this Bernoullis form in this? This is exponential function and this is trigonometrical function. So there is no algebraic function existed here. So we cannot apply the Bernoullis form. So the first thing you have to understand is, we cannot apply Bernoullis form. We cannot apply the Bernoullis method. So this is the first thing, because there is no algebraic function. So we have to use as usual. So now what we do is, first apply the Eilert principle. According to Eilert principle, what is u? U is the trigonometrical function comes first, correct? U is sin x. Exponential is the last function, right? So dv is e raised to x. Now, what is the derivative of u? Is sin x derivative is cosine x dx. And now what is v? Integral of dv is integral of e raised to x dx. Of course, this is dx. Now this gives you e raised to x. Now how to solve this? What is the formula? The integration by parts formula. Integral of u dv is equal to uv minus integral v du. This is the formula. So now let us apply this. Integral of e raised to x sin x dx is given by u is what? U is sin x. V is what? E raised to x minus integral of v is e raised to x, du is cosine x dx. Okay. So now let us do this integration. Sin x into e raised to x minus, now this integral of e raised to x cosine x dx. So how to solve this integral? It cannot be done by term by term. It cannot be a substitution. You have to use the integration by parts only. So what we do now? We treat this whole integral as some I1, let us say. Okay, we write this whole original given integral as I. We name this as I and this as I1. Okay, so I write this as I1. Now I call this whole equation as 1. Now you see this integral. Our job is now to solve this particular integral I1 by using by parts again. That is what we are doing. After getting the solution, we just plug this value here in this equation 1. So to get the function, or to get the value of this, the solution of this. So this is what I is equal to this one. This is I is equal to this. Is that clear? So our job is now to solve the integral I1. So what is I1 now? Is given by integral of e raised to x cosine x dx. So here also there is exponential and trigonometrical. So trigonometrical only is the first function, u is equal to cosine x. And then what is dv is e raised to x dx. Same way, what is the derivative of cosine x? It is minus sin x dx. And what is the integral of dv? It is v. It is equal to integral of e raised to x dx, which is equal to e raised to x. So now, what is integration by parts? What is the formula again? I hope you remember this integration by parts formula. So we now use the same. So what is u? Cosine x into, what is this I1 value? Now we are writing down. So uv, v is what? E power x minus integral of v is e raised to x. What is dv? V du is minus sin x dx. So this is what we are substituting. So now that gives you cosine x times of e raised to x minus of minus plus integral of e raised to x sin x dx. Now how will you treat this e raised to x sin x? Because this is your original integral I only, correct? So our job is now to write this I1 as cosine x plus I in the equation 1. Therefore, what 1 implies now? Implies that I is equal to sin x into e raised to x minus I1. Now I am going to plug this I1 value. What is this? Cosine x e raised to x plus I, the original integral. So that gives you, when you write this as the simplification here, I write e power x common suppose, then it will be sin x minus cosine x and minus I. Okay. So now this I, and if I take this I to the other side, it becomes 2I is e raised to x times of sin x minus cosine x. So the solution for this is what now? The solution is what now? I is given by e raised to x over 2 times of sin x minus cosine x. This is what the solution. I hope it's clear. So how we have used? First of all, there is no algebraic function here, so we cannot apply Bernoullis. So you must repeat the process twice, because again you have got the same integral here. So it is being repeated, and so we can write this I as this one. And so what is I? This is what the solution. This is what the solution of the whole integral. It's clear now. So this is what about the integration by parts method. I hope you could understand. Integration by parts we have done in 2 videos, and the first one is just by using this formula. The second one is now we have used the Bernoullis form. In the Bernoullis form only it is applicable only if there is algebraic functions are there in the integrand, then solve the integral and get the solution. With this we have finished integration, all the 3 methods. Thank you.